G'day all! So, this video here, we're going to be doing decay equations and essentially working out what decay has happened. Okay, so we'll just get straight into A here. We've got this here, 243 and uranium, and that's our mass number, and our atomic number is 92. This decays down to 230 and 90. Okay, so with this, we just need to look at what has changed. So we look at the change of the mass number. Okay, so the change of the mass number, this is the top number, okay, if you don't remember. Ooh. So we have 234 and 230. So the change for the mass number is 4. Okay, so we can 234 minus 230, that is equal to 4. And we look at the change of our atomic number. So that's the bottom one. So that's how many protons. Just remember that, the atomic number is how many protons. So this goes from 92 to 90. So that means it's changed by 2. That means 2 have left. So we now need to combine this with hopefully the theory we understand. So if we've lost 4 particles in total and 2 of them are protons, that means we've lost 2 protons and 2 neutrons. Okay, so this is a helium. So this is a helium atom that's gone out. And hopefully you do remember a helium atom, we call this an alpha particle. Okay. What happened to my P there? Not sure. So this is an alpha particle. So that is what has left. Okay. So this is just because the number of particles in the nucleus has decreased by 4 and the protons have decreased by 2. So this implies it is an alpha particle. Okay, or a helium atom or nucleus. Okay, I should probably say nucleus here because it's a helium nucleus, not the whole atom. Okay, so then we'll just write out our full equation because that's what the question says. So I'll write A and mind my horrible small writing, 234 92 U. This goes into 230 90 TH, and we'll just put it as a helium nucleus. HE, don't write H, that's hydrogen, and don't forget our energy that's always leaving. Okay, so that is our first one done. So secondly, we just do the same, alright? And I'm just going to shorthand this so you can see. So I change, just write B. So I change in mass number, okay? So 210 to 210, okay? There isn't any. So that's 0. Change in atomic number. Okay, this goes from 82 to 83. Okay, so here we have, I suppose, there's a change of -1. Okay, so here change of -1, and then we are going to go, so you do with this one, just make it aware, because you do your first one minus your second one. That's why it's a -1, not +1, like our other examples. So hopefully we can recall what kind of particle this is. Okay, so this is our negative beta particle. Okay, so it's not an alpha because the mass number remains constant, Okay, the atomic number has increased, indicating that a proton has been formed. Okay, so this is our B minus decay, and this means that we need to write this out properly. So with this, we write it out as 210, 82. Lead to bismuth, I believe. 210, 83. Okay. So with this, make sure that's a horrible one. I'll do that again. Make sure you put it as a negative one, and yet again, I have ruined it again. Sorry. We'll keep it simple. Negative one, and then E plus our energy. Okay, I'm just going to scroll down a bit just to give me room. You can still see C up there, which is good. Okay, so here we're going to be looking at, and just do the same thing. Okay, mass number, and I'll do this in red, so C. Okay, so our change in mass number. Okay, so it's 11, 11, there's 0. Change in atomic number. Okay, and we go from 6 to 5. So just remember, this is 6 minus 5, so this is equal to positive 1. So just make sure that you get your positive and negatives right. Okay, so this will be, and hopefully remember, is our positive beta particle. Okay, so just why this happens, our mass numbers stay the same, but there's one less proton. Okay, so there's one less proton, and this indicates our positive beta decay. So our equation then just is, and we'll write it just like here up the top, 11 6C. That becomes 11 5B. Just make sure, especially here, that you put positive 1 and 0 energy, electron plus energy. And I went way too far on my R there. So with this, whenever you get these types of questions, first you need to remember your types of decays there are, okay, and what makes them up, okay, what's happening there. So make sure you do remember that. And then all you need to do is take away your mass numbers together, take away your atomic numbers together. So just make sure you do the first one, okay, what's on the left? Oh, it's annoying, tried to scroll up and it's whatever's on the left hand side, okay. So for the first one, for example, we did 234 take 230, and more important, the bottom one normally tells you what kind of decay it is. Okay, so we have 210, oh sorry, not 210, that's the next one. We have 92 minus 90. So just make sure that you get them the right way around, especially when looking at these last two examples here. Okay, if you don't get them the right way around, okay, you'll get the wrong particle for each one. So you'll get the wrong particle here if you don't do it the right way around. So just make sure you do that, and it's just making sure you're not making any silly little mistakes, really. Okay, so good luck with that, and hopefully this helps with these types of questions. Just make sure you look up on what type of decay that we have. Alright, so good luck.